All right, class, on the last lesson we just finished up, we got this 577 on converting 4,302 into decimal notation from base 5. There's a new, or it's not new, another method that might be a little bit more straightforward for you as I was showing you to work backwards from our base here of what units of 1, and then units of 5, and then units of 25, and so on. There's something called Horner's method, and let's take a look at that. Horner's method, if you follow the steps over here listed on the left, what you do is you start from the left-hand side of the number, and you actually work your way backwards. You still end up doing the same calculations, but it might be a little more straightforward for you, as you start from 4 and you multiply it by 5. And then you add the 3, which is this 3 right here, and you get 23. And you take that answer and you times it by 5. And then you add the next number, 0. That gives you 115. And then you take that and you multiply it by 5. And then you take that answer and add the 2, the last number that was up there, and that would give you the same 577. So it actually is a very quick way of converting. So, for example, if I wanted to do 3,093 and it was base 4, say, what you would do is you take the 3 and you would times it by 4. You would get your answer of 12. And then you take the 12, add the 0 right here, and then you times that answer by 4, so 12 times 4, and that is going to give us 48, and then we take our 48 and add the 9 to it, and then you take your 57 and times it by 4, and then you would take that answer, add 3, and we'd be done. And so that's going to give us 228. And then if we add 3 to it, this last 3 over here, and that's going to give us our 231. And that is what, so 3,093 base 4 is really the number 231. So let's go ahead and take a look at our next concept here. So we're going to write 384 as a base 5 number. So this is just 384 right now, the way that it's written, and we want to write it in base 5. Now the way to convert a regular number into a different base, as we've discussed before, is to take our number, and divide it by our base. So we've got 384, and we're going to keep doing division with 5. And then you're going to take your answer up here, and you'll have a remainder, and we're going to end up breaking it down. Let me show you a different way that I've got here. We're going to take a look at doing the division this way. This is the long division that you would have done, but so we've got 384 dividing by 5. What we're doing is we're just writing the remainder off here to the side. This is what the leftover amount would be after you subtracted 5 times 76. Sorry, I was looking at the wrong number. After I subtract 5 times 76, you end up getting your remainder of 4. And then if I do the division again, I get a remainder of 1. And if I do the division again, you get a remainder of 0. And so what we're doing is we're dividing this way by 5. So let me kind of show you how this works. So if I had done my division of 384, as I wrote a moment ago, by 5, I would have got 76. And then if I multiplied 5 times 76, that gives me 380. And so then the remainder that we're talking about is the 4 here after I subtract. Okay, so this is my remainder. And then so what I need to do is take my 76 and divide it by the 5, and what I do is I get 15 times, and then I have a remainder of 0 because it goes in, well, remainder of 1, I'm sorry. So you get 75, then you subtract, you get a 1, And then so we take our 15, and it goes in 5 times. Or how many times did 5 go in there? We get 3. And then it goes in evenly, so we have a remainder of 0. And then that's where you stop, because it goes in evenly. So what we're doing is we're taking these remainders. We have our 4, our 1, our 0, and this last number is our 3, because that's how many times evenly it went in there. And then so what we're saying is we start backwards. So we start at the last number that you end up resulting in, then you put the remainder, then you go this way to the 1, and then to the 4. And then so if we actually read the remainders in reverse order, you can actually write your number of 3, 0, 1, 4. And then I'll put my little base 5 to make sure that that's actually what it looks like. Okay, so that way we know it is base 5. And there we go. Okay, so this is just showing your division as you work down, the numbers that we'd be getting, and then our remainders, if you write them backwards, starting from the last resulting number when the remainder is 0, so you stop when the quotient is 0, the remainder is 0, and working backwards with your leftover amounts, this gives us your number. So here we go. We're going to add with base 5. This is a addition table with base 5, and so what you can see here is we've got our 0, 0 and 0, of course it's 0. If you have 1 and 1, and so on, these are all just your basic addition until 4. You had 4, 0. Then here where we have 4 and 1, this is where we get our 10 base 5, because it's 1 group of 5 and 0 leftover 1s. If I do 4 and 2, that's 6, and so it's 1 group of 5 and then 1 more number. Okay, so this is just doing some addition with our base 5, as you're going to be asked to do in your homework. So what we're going to be doing here is we're going to be adding base 5, or adding in base 5, and we're going to add it vertically just like we do with our regular numbers. And so we're going to do a lot of adding and carrying just like we know how to add. It's just that when you add numbers like 2 and 3, it would have resulted in 5, but because it's base 5, we never actually write 5. What you do here is you write a 0, and you carry the 1. So just like we would have said, well, 9 plus 1 is 10, we wouldn't have put 10 here, we put 0 and 1. So that's how this works in base 5. So here we're going to add, we have 4 plus 1 is 5, 6, 7. So what you do is you put a 2, and you carry the 5. So in other words, this represents 5, plus 2 is the 7. Then you add again here, 3 plus 2 is 5, plus 1 is 6, so we put a 1. And then just like we would have said any other number bigger than 10, this represents the 5 and the 1 to be a total of 6 for this column. Okay, so it's exactly how we add with regular numbers in base 10. It's just that as soon as you get to a 5, that's when you need to put a 0 or your leftover amount if it's 6, 7, or 8, and then you carry the 1 on over. Okay, so this is your resulting number is 1,120 base 5, which is the result of what these numbers would be if you were adding a base 5. So we're going to do subtraction also, and what we've got to do here is just subtract 4 minus 3 is 1. And then here we come to a problem because we need to borrow. This number is too small. So you need to take one of these away, but it's not 12 when we write it. I am going to add I wrote a 1 there. I meant to take away a 1. So left over you have 3 here, and you're borrowing a 1, but you've just got to be careful. It's not 12. This is a unit of 5, so it's really 5 plus 2 is 7. So 7 minus 4 is 3. I hope you're following that there. This is a 2. This 1 represents a 5. 5 plus 2 is really 7. Okay, so this 5 is that 1 is representing a 5. And then over here we have 3 minus 1 is going to give us 2. So this is 231 base 5 is what the result of subtracting these two numbers would be. Okay, so there it is a little bit more clearly if you need to read through that a little bit more of what I just explained. Okay, so multiplication with base 5, here's our multiplication table. And obviously everything stays the same until you get over here where you're doing 4 times 2, where you're going to end up needing to do 8. And 8 is represented with a 3 plus 5. This one represents a 5, and another 3 gives us a total of 8, and that's what 4 times 2 is. Okay, so over here you've got multiplication happening that we've got to try out. And so we want to go ahead and take and just multiply exactly how we would have done with base 10. You take your 2 and times it by your 4, and it just continues to naturally progress just the way that we do regular multiplication. And so we take our 3 and times it by, or sorry, our 2 and multiply it by the 4. And of course, 2 times 4 is 8, and so you represent the 3 down here and the extra 1 to be our 8. Okay, and then what happens as you continue, as you continue to multiply the 2 times each one, we get these numbers progressing over, and then what's going to happen is we're going to end up adding a space over and doing the 3 times the 4 to get 12, and then 12 is 2 groups of 5 plus a 2. Okay, so let's go ahead and multiply this out. So that's a little background of what's about to happen for us. So 2 times 4 is 8, so you would put 3 and 1, and then 2 times 3 is going to be 6 plus 1 is 7, so you put 2 here, 1 here. So this is a group of 5 plus 2 for our 7. And then last, our 2 times our 1 is 2 plus 1 is 3. Okay, so that's multiplying with the 2. And then you add your space or your 0 there. I always write a 0 rather than just jumping over, but now we multiply with a 3. So we'll change to red to do that. So 3 times 4 is 12. And so 12 is 2 groups of 5 plus 2. So we write a 2 and we write a 1 up here for 12. And then 3 times 3 is 9. 9 is 1 group of 5 plus 4, so we write 4. And then we put the 1 over here to carry that 1. And then 3 times 1 is 3, plus 1 is 4. And then you go ahead and add just like you do with regular multiplication. It's just that these numbers, you had to carry the 1 for a group of 5. So we've got 3, 4, 7. 7's a problem, so we have to turn this into a 2 and carry the 1. And then we put 4 plus 1 is 5. Okay. So anytime you have a number that's 5 or bigger, you've got to carry that 1. Just like here, we actually end up with a 5, so we have to put a 0 and then put a 1. So our final answer is 10, 2, 4, 3, base 5. Okay. So good luck in this section. If you have any questions, send me an email through the Ask My Instructor feature of the lab.